Alright, so let's do a couple of these together now, and then you'll get one to try on your own. We're in 2.1, and I'm going to call this page 2c, because this is the third video. We broke this page up into several because there was lots of talking going on. That's me, just trying to be super descriptive so you can get your questions answered, rewatch things, try to understand what's going on. This isn't the only way to solve equations. There's other ways to think about it and show it and demonstrate it. And of course some of these are just can do in my head, and many of you will say, do I have to show so much work? In the sense that the answers are in the back of the book, yeah, I need to see kind of what's going on. I need to see what you're adding to both sides. I do need to see that one step. But in terms of the extra lists that I make on the side, you know, you choose what is going to help you the best. What I'm doing, my plan here, is to show you all the steps so that as the problems get more difficult, we're set and ready to go. Okay, so now just treat it as a checklist, and some of them are already done for us. So let's look at number 18. Negative 21 equals y minus 4. And if you look at it and go, I'm not sure what to do, ask yourself, well, what's different about this problem? In this case, the y is on the other side of the equal sign. And then once you've answered that question for yourself, what's different, then you need to trust that the steps are still going to take you where they need to go. So let's follow that through. Keep our goal in mind, that we want to get x all by itself, or in this case it's a y by itself on one side of the equal sign. Isolating that variable, solving what the value is equal to, the value of that variable. So let's look at what we need to do first. We need to simplify, which means we're checking on both sides of the equal sign if there's any grouping symbols, parentheses that we need to take care of, and in this case, nope, it's done for us. Then we're checking for like terms, so again, looking on both sides of the equal sign, kind of covering it up here and just looking at the expression on the right side, no like terms. Just looking at the left side, single number. So like terms are already combined for us. We also then pick a side for the variable to be on. So y is on one side. It's not on both sides. We don't have to move it. But for those of you that are more comfortable with y on the left side, you do have the option. You could use the opposite operation to get y to the other side. It would mean in this case there's a plus, we don't see it, but when you don't see the operation, it's the value in front, it's the sign in front of the variable. So you wouldn't add y to both sides. This minus applies to the 4. Okay, but you would subtract y from both sides. Now, I'm not going to do that because it opens up the door to a second step, and we're not going to worry about that one right now. We're going to hit that in 2.2. But you're welcome to put it on a different side at any point. I'll demonstrate how to do that a little bit later. Or if you want to see that in class, that would be fine too. So you pick a side. It's already done for us as well. You'll notice in this section all three of these will be pretty much done for you. You don't have to worry about it. Then we look to start solving, which means we're asking ourselves, what's happening to the variable? What's happening to y? So just focus on y and cover up the rest. If we were to put a value in for y, what would we have to do to it according to order of operations? Well, we'd have to subtract 4. So the first thing and the only thing in this case is we would subtract 4. So that's the verbal version here, or you could do it in kind of a visual version of it. You would say y, you have your y, then you subtract 4. And meaning we're going to read that from left to right there, because that's what's happening in the original. Then we go back and we say, okay, to solve it, we're going to undo what's happening to y. We're going to undo it, which means that we're going to go up the list here. So if it was our list 1, 2, 3, 4, you'd start at the bottom and work your way up the list, making every operation opposite. So instead of subtracting 4, it's going to become add 4. Or if you wrote it out in kind of this visual method using letters and numbers, you wrote it from left to right in terms of what's happening. You go backwards through that from right to left. And in this case, the first thing you'd run into is the minus 4. You make that opposite to be a plus 4. And now you are telling yourself, what you've done here is you've created a list. Now, there's only one step, so it's not much of a list, but it will be once there's more than one step involved of what's happening to the variable. Soon, soon, soon. So you've now created a list that tells you to go ahead and add 4 to both sides, so that's what we're going to do. And we get that the equal sign comes down, the variable comes down. We haven't done anything to that. But we have added 4 to that -4, that -4, however you want to think about it, and that goes away. That's the whole point. We were aiming to get rid of what was happening on the side where y is. And now we've got a -21 plus 4, that gives you a -17. And we've got y all by itself, so we now have our answer. It's time to check it. So we go back to our original -21 equals y. Write that very clearly, sorry. -21 equals y minus 4. I'm going to plug in that y value and see if it works. So I get -21, -17 minus 4 is -21. It's a true statement. So that means I have my answer. I'm going to put it in set notation. I've checked it. It works. I have my answer. I'm going to put it in set notation. And my answer up here was -17. Sometimes I get a little distracted and I will go for the number right here on this last line, and I have to remind myself, no, -21 came from the fact that I was checking my answer. I need to go back to where I see y equals, and that's my value that I put in my set notation. All right, let's try number 22. Then you'll get to try the one on the bottom here. And this one, y is on that comfortable left side that most of us are really used to seeing. So it may not strike us as anything different, but if a problem ever does, just pause and ask yourself, what's different? What's causing me to go, I'm not sure I know how to start this? Then ask yourself what's different, answer that question for yourself, and then trust the process, trust the steps. And the first step then is to check for simplifying. Is there anything we need to do to simplify this, which is really our way of saying we're trying to rearrange it to get it to where it looks like ax plus b equals c. Are there any parentheses? And as you look to the left side of the equal sign and the right side of the equal sign, this has already been taken care of for us. We don't have any removing of parentheses to deal with. And then we look to see if there's any like terms that can be combined. And again, this is just on one side of the equal sign or the other, okay? And there's not. It's already been done for us. And then we just make sure that y is on one side or the other. So we pick a side. In this case, y is on the left side. For many of us, that's the most comfortable because it's only comfortable because that's the way we've seen it so much, okay? That's the majority of how we've been exposed to it. So that's what feels most comfortable to us. We like what we're familiar with, okay? If you've ever had the situation where a song comes on the radio and you just hear the first couple bars, so your brain hasn't had time to really realize what song it is, but you have this sense that you like this song, and then you realize just moments later that what the song is, and you realize, I don't like this song. It could be because the song was overplayed when it first came out, and you became familiar with it even if you didn't like it. You were exposed to it over and over again. Later on, as it comes on the radio, your first instinct, because of that familiarity with it, you heard it so many times, is that, oh, you like it. So familiarity breeds likeness. It breeds an appreciation for things. So it's an interesting phenomenon with our brain. But anyway, so we just tend to like the variable being on the left side because we're so used to it being there. And most of us end our solving by saying y equals this or x equals this. So we're just left side dominant apparently. Okay, now we're going to start the process of solving. So it's already been done for us. It's in that ax plus b equals c format. Now, the y and the -8 are kind of switched around here in terms of ax plus b equals c. We're kind of looking at a b plus ax equals c format, but that's okay too. If you really feel the need to switch it around, just make sure you keep that negative right attached to that 8. It belongs to the 8 and no one else. Now we're going to ask what's happening to x. Oh, I'm sorry, to y. What's happening to y here? And as you look at it, if we, again, cover up the other side where y isn't, ask yourself, if I put in a value for y, what would I have to do to it? Well, you'd have to add a negative 8 to it. So that's our one and only step here. We're going to add negative 8. If you wanted to, you could subtract 8. That would mean the same thing. Okay? Or you could write that as subtract 8, whichever one makes more sense. If you do that in more of a visual look, you would write that as y. Again, we're not copying what we see here. We're writing out from left to right, kind of in storybook form here, what's going to happen to y. So you can write that as that we add a negative 8, or you could say, well, the very first thing that happens is we subtract 8. Now, if you aren't at the point where you can totally agree that these two are equivalent statements, add negative 8, subtract 8, then I want you to make sure that you are getting some extra help on positives and negatives. Okay, this is going to be critical that you understand this. Or you could write this as a y plus a negative 8. Okay, and go that direction. So that's what's happening. It's just one step long. We'll get more as we go through this. But now go up the list. There's just the one step here, so we're going up the list. Or go backwards along that line, right to left. As we go up the list, we'd either change, depending on which one makes more sense to you, either you're adding a negative 8 or you're subtracting 8 from y, whichever makes more sense to you, and you make those opposite. So either we're going to add 8 or we're going to subtract a negative 8. And subtracting a negative is the same as adding 8. Okay, so either way, we're going to be adding 8. It's either as a subtracting a negative 8 or just adding 8. In the same thing here, if we go and do the opposite, subtract 8, the opposite would be to add 8. Or if we said it was a plus negative 8, it would be subtracting a negative 8. The number doesn't change, it's the operation that changes here. And adding a negative 8 is just the same as adding 8. Okay, so that's what we're going to do to both sides. We're going to add 8 to one side, add 8 to the other, combine those two lines together. The y comes down, the equals comes down. The negative 8 is plus 8 is now 0. That was the whole point. We were trying to get rid of it. Negative 29 plus 8 is a negative 21. And we want to check that. You can do the check in your head or on paper. But you do it back in the original equation. So negative 8 plus y equals negative 29. We're just checking to see if we put negative 21 in there, will we get a true statement? So negative 28 plus a negative 21 is negative 29. Both sides are equal there. So this is a true statement. I've checked my answer, so now I get to use set notation and put my answer of negative 21. It's kind of like the super elegant version of, if we were to circle our answer or box our answer or highlight our answer. Set notation. Okay, so take a moment to talk through this page with somebody and really kind of let these steps sink in, because we're preparing ourselves for when these problems get harder. Okay, please don't take the easy road and just go, I don't have to worry about those now, I can solve these all in my head. Okay, but you're making it harder than you need to for yourself for later. Now, on the other hand, if you know solving equations, you've got this down pat, and you've already kind of skimmed ahead to see what the problems look like in 2.2, 2.3, and beyond, and you're thinking, I got this, no problem, then you aren't going to need this method. This method is a pull apart, back to the basics, let's start over and really learn how to do this. For those of us who solving equations has been a struggle, that it has always been always a little bit of doubt. Is this how I start solving? Do I add or subtract? Do I multiply first? Do I divide first? What about the negatives? If there's that little bit of doubt about solving equations, then this method is going to erase all that. You're going to get there. Okay? All right, so once you've talked it through with somebody and kind of decided on how you're going to tackle these problems, remind yourself what set notation is, start practicing that, start using it, and then try this one down here at the bottom, number 36. Hit pause if you don't want to see the answer yet, because here it is. It should be negative 19, and hopefully you started practicing set notation and put it like that. Good job. We will see you on page 3.